Welcome back. So we are learning about solving the circuits with the series and parallel combination of resistors. So let's have a look at our next example. So we need to find the equivalent resistance for this given circuit from these two nodes. Okay. So let's label them. Okay. Let's say that this is node A and let's say that this is node B. Okay. Just for the simplification. Labeling the nodes always makes it easier to solve those circuits. And then we can say that basically this whole thing is one node. Okay, let's call this C. Then this could be our second node, which is basically connecting, okay, this one. Okay, let's call this D. Okay, and let's call this one, okay. Okay, so basically E, just for the simplification. Actually this could be the same nodes, but we will discuss later on. And let's call this one as a one node, which is basically F. Okay, so let's like some nodes will be the same. Okay, we will see that thing later on. So but I just label them differently to make it easier to start. So if we start from the end of the circuit, we can say that basically this 12 ohm, this 12 ohm, so they are connected at this node and they are also connected basically at this node, okay, which is basically C, or you can say that basically the E, same thing. So basically 12 ohm and 12 ohm, they become, because they are connected between the two nodes and they are sharing two nodes, so they will be in parallel, right? So they will be in parallel, and 12 ohm and 12 ohm parallel, what will be that? So 12 and 12 parallel, so 12 times 12, our 12 plus 12, or like 1 over 12 plus 1 over 12 inverse. Okay, either way, it will be equal to 6 ohm. So let's redraw our circuit, okay? So we have basically this 12 ohm here. Okay, so this is this line, and then I have this 12 ohm here. This is where we need to find out our equivalent, and I have this 12 ohm here. I have this 12 ohm here. Okay, and I have this 12 ohm here. Okay, so this is all connected at the same line. Then I have this one here, and I have straight line here. Okay, so this 12 and this 12, they become basically parallel. So parallel becomes 6 ohm. So this is coming basically between what? Node D and C or E, okay, whatever you label that. So basically that thing is coming here, okay. So this was basically my node D and this was basically my node E or C, okay, whatever you say. So what is the value here? 6 ohm, okay. So that will be our 12 and 6 ohm parallel here, okay. So but other than that, okay, what we have here now? Okay, this is the point where we want to find the equivalent resistance. Okay, so this is 6 ohm, but also we can say that basically there is one more line, okay, like this line, which is basically connected between D and C. Okay, so we can draw this line just simply here. Okay, so this is basically the line between D and C. Okay, so we can say that now, again, what we have between these two lines now, we have 6 ohm and a simple short circuit line. Short circuit line have a resistance of 0 ohm. So basically now we have a 0 ohm parallel with 6 ohm. So 0 parallel with 6, that will be basically 0. Okay. So in other words, what we can say that this 6 ohm is basically shorted. Okay, shorted means 0. Okay, this will become 0 between D and E. So if I redraw this circuit again, now how it will look like? 12, 12, 12, 12, and we have this 12 here. So this was the same point, right? D. And now 6 and this one, this will become 0. So basically 0 means simple short circuit, right? So this will become short circuit. Okay, so that will be our next circuit, okay, after this one. So we can also do this thing directly here. For example, we see that a branch between D and E or C, E and C is same, is 12 ohm. Then between D and C we have 12 ohm. Then between D and C we have basically some simple this line, okay, which is a 0 ohm. So 0 ohm parallel with 12 ohm parallel with 12 ohm, that will basically become 0 ohm. So we can connect just simple one line here, okay, between D and E. Okay, now what we can see next? Okay, so you can see that basically now we have this point which is basically our D or E, which is basically same point now. Okay, now between these 2 points what we can see, we have this 12 ohm, and this 12 ohm is basically in parallel with this another straight line, right? Okay, so this was basically point A. So this 12 ohm is connected between A and E, and between A and E we also have a simple straight line. So basically again 0 ohm parallel with 12 ohm, so that will become 0. So it means this 12 ohm is also basically shorted, right? This 12 ohm will also be shorted. Okay, and you can also see that on the bottom side we have this 12 ohm and this 12 ohm. So this is sharing node A, and what is this node second one? F. Okay, so it means they are in parallel, right? So the combination of this 12 and 12, that will give me 6 ohm, right? That will give me 6 ohm here. So what will be our circuit next? Okay, so if we redraw this circuit again now here, so we have a 6 ohm. Okay, so let me put it like this way. So here I got basically a 6 ohm resistor which is connected between basically A and F. Okay, so this between 12 and, okay, like this was E and this was F. Okay, so this actually become what? That will be shorted, right? So we are left with what? Okay, a simple short line here, right? Between a simple short line here, this is of that, and this is 6 ohm. And then on the other end here, what we have here? We have a 12 ohm, and on top we also have this 12 ohm. Okay, and this 12 ohm is connected between basically now, okay, between point A and, okay, like this is B and this is our point A, right? So our circuit like this 12 and 0 become short, so this simple short, and then we have 12 and 12 6, and we have here. So we are looking from this end now, right? So if you now look, if you look at this end, what we can find? That this 12, okay, and this 6, okay, so they are sharing basically this node, okay, so they are in basically series, right? So 12 and 6, that will basically become 12. So if we redraw the circuit again, okay, what we can get here, we have just one resistor which is basically 18 ohm. Okay, and here I have another resistor, so let me just draw it like this. So this is 12. Okay, so this is point A and B, right? This is A and this is like B. So now between A and B, what do we have? We have two resistors, okay, which are basically sharing two nodes. Okay, so what will be the equivalent? RAB. So this 12 and 18, they are in parallel, right? So that will be basically our equivalent resistance. So what is the parallel of 12 and 18? So 12 times 18, our 12 plus 18. Okay, so that will be basically equal to what? This will give me an answer of 7.2 ohm. Okay, so this is how we can solve such kind of circuit. Thank you.